Imagine a world where our most advanced technologies are driven not only by innovation, but also by responsibility. That's a world that we will explore today in this session. Welcome, my name is Jawad Sardar. I am the CEO of Sum Global, a specialist consultancy working within the smart cities and technology space, and also director at Richmond Global, a boutique consultancy working within the sustainable mining space. So today we will dive into the crucial intersection between sustainable mining and the AI revolution. And as we move into the AI revolution and the AI revolution grows, we're pushing the boundaries of technology every day. And as we push these boundaries, there's a critical need for us to address the environmental and ethical questions and challenges around the sourcing of raw materials for the AI revolution. So before we start, just a quick introduction on Richmond Global. So we are a boutique consultancy working within sustainable mining. We are helping the industry transition from a very traditional and quite fairly outdated industry to a more technologically driven and sustainable industry that can help shape the future that we live in. And our work lies at the intersection of technology, sustainability, and critical minerals, the very elements needed to shape our future. So, the AI revolution, it's reshaping our world at a breakneck speed. But what's fueling this revolution? Is it data? Is it algorithms? Is it GPUs? Is it CPUs? It's all of that. But before all of that, it's the critical minerals that lie beneath the floor that we stand on. And it's this AI revolution that is driving an unprecedented demand for critical minerals, and a demand that comes with an incredible responsibility. We can't repeat the mistakes of our past industrial revolutions, and we must find sustainable ways of meeting these demands without affecting the environment and exploiting vulnerable communities in places where these critical minerals are found. And this is not just an environmental imperative, it's a business one too. So companies run the risk of losing their social license to operate if they're not sourcing materials in a sustainable manner. And this is something that I believe that the tech industry has been very shielded from, where there's been minimal questioning and accountability around the sourcing of metals and minerals needed to develop our IT systems and our devices that we use on a daily basis. So what are critical minerals? These are not just rocks and metals. These are the building blocks of our technological future. They play an integral role in our day-to-day lives, and a number of these, I'm not going to test you on which ones, play a pivotal role in the development of our handheld devices, our laptops, our computing systems that we then develop our AI systems upon. And the challenge here is not one about quantity, but it's about access to such a diverse number of minerals, each of which is found in different geological geographies and have a distinct extraction challenge and supply chain risk associated with it. So what's the critical challenge at the moment? So it's about meeting this demand in a sustainable fashion, not committing the same environmental mistakes we made in past industrial revolutions. And how do we create a stable supply of these minerals in an increasingly unstable world? And the only way we do this is through collaboration, building resilient, ethical supply chains that can withstand geopolitical shocks. And a supply chain that meets the increasingly stringent ESG standards that the world is now being held accountable to. But how do we go about doing this? We live in a world at the moment where China has stormed ahead and no sort of negative impact in that sense, in that they understood the demand and the industry decades before others did, and have stormed ahead in terms of their capturing of the market. But how sustainable is a global mining sector or global critical mineral sector where the global supply is controlled 99% by a single economy? And this is reasons why we are having these challenges around the development of electric vehicles, the access to minerals, the semiconductor fabrication wars. And just last week, for those of you who follow the industry, there was export controls instilled in China around the exporting of anti-money because of the increased local demand and domestic demand in China, which has meant that anti-money semiconductor fabrication companies outside of China are now having to pay 10 to 15% premium on accessing anti-money. So what are countries like the UK trying to do? So our government, in collaboration with others across Europe, US and Canada, are trying to take on a leadership role here. And the emphasis is on trying because we are very far away from establishing that position in the market. But what the UK is trying to do is show that it's not just about digging holes. This is about creating ecosystems and cultures of innovation and sustainability. This involves developing domestic capabilities, fostering international partnerships, and also driving innovation that can help build more sustainable extraction techniques. And this is done in collaboration with our international partners through something called the Minerals Security Partnership. And this isn't just an agreement, this is a vision for a more sustainable future. It's about creating communities and a culture of commitments to sustainability and community of practice. And the partnership has the potential and opportunity to really transform the mining industry from its more traditional and outdated space that it's in at the moment to a more sustainable and technologically advanced industry that it can become. And through this partnership, we can potentially move into a space of collaboration rather than competition. And the MSP framework is fairly comprehensive. So we're not just addressing extraction, we're looking at the entire life cycle of critical minerals. We have over 14 economies that have signed up to the MSP, including the UK, the US, Canada, most of the EU, Australia, and now, I think, as of last week, Argentina too. And the focus isn't just on extraction, it's on things like recycling and how we can use existing materials that are out there in the world to recycle them and plug them back into that ecosystem. And as we move forward, these circular economy principles are becoming much more important. And so the principles aren't just guidelines. These are a philosophy that could potentially transform the industry. It's one where prosperity and sustainability go hand in hand and take a much larger and more important seat at the table alongside profit margins. Environmental stewardship is not just about protecting the environment, but it's about having a positive impact on the environment. Community engagement goes much far above and beyond just consultation, and it's venturing into spaces like co-creation. And ethical business practices are now no longer optional, but the absolute standard. And if you want to engage on these principles and you want to access these opportunities, you have to commit to these ethical business standards. So this is where it becomes interesting, and I promise you it does become interesting beyond just the frameworks and the principles. So there's a beautiful relationship between tech and mining. It works in a almost autonomous circularity relationship where critical minerals are the fundamentals upon which AI will grow, but AI can play a key role in the development of a more sustainable extraction and mining industry. It's a virtuous cycle of innovation. Imagine minds that think. What Industry 4.0 and what AI and other sort of machine learning and other technologies are doing for mining is not just about the machines. It's about creating an innovative ecosystem that can optimize every aspect of the mining process, from extraction all the way to the marketing and sale of the minerals. We have AI technologies deployed on exploration and construction, from satellite technology to radar systems on the ground. Within the drilling and blasting systems, we have tech deployed at all elements with IoT and sensors analyzing and making judgments on machine capabilities and use time. And everything up to the smelting and the processing element, where we have machines that are optimizing the efficiency and the purity of our end products. So what does this look like practically? So Koch Digital, which is a joint venture between the Koch system, the IT systems integrator wing of the Koch business group, and the Boston Consulting Group, have in the recent past deployed a lot of this technology on some of the gold mines that the Koch Group own. And what's been the result of that? So AI isn't just predicting when machines will fail, it's actually making decisions for the next few years within the gold refining process. It's making mining more safer, and it's making it more efficient with significantly less waste. And it doesn't just stop at maintenance. So here with AI, we're optimizing resource, we're minimizing waste, and we're reducing the environmental impact that traditionally a mine would not be able to avoid. And this is all through the power of data and AI. But technology isn't just about efficiency, it's about people. So AI systems aren't just preventing accidents, they're also instilling a culture of safety and security and trust, something that's always been absent within the mining industry. It's showing us that sustainability is above and beyond just the environment, but it's about people, it's about communities, and it's about our responsibility to both communities and local environments. So here's a real game changer. Fodere Titanium, a UK company born out of academia, Leeds University, for anyone who has visited the north of England. This was a R&D process that was developed out of Leeds University by 2 PhD students, taken over the last 8 years from a lab setting within the university to a industrial setting now, where they are extracting vanadium from mine tailings across the world. So these are mine dumps that have left hazardous waste lying on potential farmland and agricultural land to now affect and pollute the soil and also the waterways downstream. So what Fodere Titanium are doing are using those mine tailings, have a zero waste, economically and environmentally friendly process to extract vanadium, which is a critical mineral used in vanadium redox flow batteries, which are an alternative to lithium-ion batteries in energy storage systems. And it's not just about the environment. They're also creating jobs, they're reducing the energy consumption, and they're developing skills programs around local capabilities and helping local communities be part of the project rather than being effectees of the projects. So what does the path forward look like? So we have 2 choices here. We either stick to the traditional, blind eye, not ask any questions, continue to develop our AI and technologies without asking where the semiconductor components and chips are sourcing their materials from and how many casualties, how many communities are being affected by that process. Or we can move to a more sustainable, innovative, technologically led process, and one of more accountability within the tech industry, where we're asking questions around where our critical minerals that are powering the industry are coming from. And as we stand now at the crossroads of technology and sustainability, we have a choice. We can have a technologically powered future where we deploy AI and other technologies on the mining sector and make it more sustainable. And we commit to a more responsible, innovative, and shared future. And we make a world that's more kinder for us to work in, and one where technology takes a leading role and responsibility in the establishment of communities, sustainable sourcing, and really leads the conversation that then other sectors can learn from and can adopt from. Thank you very much.